then we will work until then. Alrighty. So, before we do anything with trigonometry, which is the next step in triangle work, I quickly want to review two things about triangles in general. All right. The first thing is Pythagoras, which you all already know. I just want to quickly remind you of how it works. That triangle is a right triangle. What makes it a right triangle? How do you know it has a right angle in it, Jack? Because it's got that little box. If that little box is not there, do you know it's a right angle triangle? No. Can you prove it's a right angle triangle even if that box is not there? Yes. How? What would make that a right angle triangle? Jack? Okay. If this triangle follows Pythagoras' rules, it's a right angle triangle, whether the line's there or not. Understand? Okay? So this is a right angle triangle. Automatically, even without the little box there. Okay? This is a right triangle because it has the little box there. Okay? If you have that little symbol there, that means you can do Pythagoras. If you don't have the little box there, you must use Pythagoras to prove the right angle. Does everybody understand the difference here? Because you know this is a right angle, you're allowed to use a squared, b squared, c squared to find x. Because it's a right angle. In this one, you can use ABC to find if it works, this gets a right angle. Does everybody understand that difference? Okay? Just because this looks like a right angle, if you were to do the math and it didn't work out, you could not say it was a right angle. Does everybody understand? Yeah? Okay. Now at the beginning of the year, well, not the beginning of the year, like the third unit, we talked about Pythagoras, we drew a square, we talked about why Pythagoras works. Okay, I'm not going to review that. I just need you to know this. Okay? Pythagoras comes in two flavors. A squared plus b squared equals c squared. And that will find what? Not fid. That is what we use to find an hypotenuse. And c squared minus b squared equals a squared. That will find either leg. Does Myers like referring to it as a squared, b squared, c squared? No. Why? Because it can be any variable. I could even give you this. Would a squared, b squared, c squared work on this red triangle? Why not? Because I put the hypotenuse in for a. All right? So I don't like using that. Right? I prefer to say leg squared plus leg squared equals hypotenuse squared. Because the legs are interchangeable in the equation. Does everybody understand that? Okay? That's what I like to use. Everybody is good with Pythagoras? Okay. Now, next thing. On the same piece of paper, because you still got should have a lot of blank space still, I want you to remind yourself of this. Draw a little tiny triangle. that has a right angle in it. Okay? That is 1 by 2. And then we could use Pythagoras to find the hypotenuse, yeah? All right. Now, draw a slightly bigger triangle. Everybody cool? Everybody's cool? Okay. The bottom is 75,212. The vertical one is 115,218. How do you find the hypotenuse? Pardon me? Leg squared equals hypotenuse squared. Right? Okay. Draw a third triangle with the long side, then down, then up. Put that in there. This long side is 0.00001, and this side is 0.00001. How do you find the hypotenuse? Same thing. Does it matter that I turned it? No. Does it matter about the size? No. So what does that tell us? It always works. Pythagoras always works. Size doesn't matter, right? Everybody good? Okay, that's lesson 1 from today. Lesson 2 from today is going to be this. Hopefully you have a little bit of room. Draw a triangle. It doesn't need to look like mine, but make it longer, make it an isosceles. Okay, 2 long sides and a short side. All right, everybody cool? Now, I am going to actually measure them and give you the actual measurements. Wow, that's crazy. All right, everybody good? Okay? All right. This is lesson 2 of today. A, B, C. Corners, which are really called vertex, not vetex. A corner is a vertex. This has 3 corners, so it has 3 vertices. Because vertices is the plural of vertex. Like the plural of index is indices. And the plural of appendix is appendices. All right? 3 vertices. We label them capital. All right? Sides are across from your corners. And we label them small. Okay? So this is my corner, my vertex A. What name will this little side get? Or this side, I mean. Little A. What will this side be? Nope. Little b. What will this side be? Little c. Is everybody good with those 2 pieces of knowledge? Right? Okay. 1, Pythagoras always works, no matter the size of the triangle. Right? 2, this is how we label a triangle. Everybody good with those 2 things? All right. Now, we're going to move on to the next page. You do not need a ruler. You can just sketch. That's why I used graph paper. I did it on purpose. All right? Now, do you guys have ED here? Okay, scribble that out. Because I had to make this smaller to fit the way I wanted it to. I only need those three. All right. Everybody ready? Okay. Make the triangle AFB. You can make it with any color you want. If you have different colors, it doesn't matter. AFB. Everybody cool? Everybody cool? Easy peasy, yeah? All right. Now, I want you to compare the following ratios. Ratios mean we're comparing the two, yeah? So how far is it from B to F? 3. How far is it from A to F? 4. 3 to 4, yes? What's another way I can write that ratio? For example, there were 4 questions on the test and you got 3 of them. I can also write that as 3 over 4, can't I? What is the third way I could write that ratio? Or a third way? If you have 3/4, how much money do you have? 0.75. Yes? And a fourth way you could write it would be as a percentage. 75%. Is everybody comfortable with those 4 things all being the same thing? Everyone is good? Okay. Now, C to G. I'm going to change colors to blue. It will be slightly more difficult for you guys to see it, that the color change, but I'm going to do that anyway. C to G in blue. Yes? Everybody is good? All right.
Good afternoon. Excuse this interruption to your lessons. At this time, we'll be asking the students who have already purchased a buyout ticket or a complete pass for the snowball.
So much for 12:30.
To make their way to the pit to see the game between our Panthers and Stardust. At this time, with teacher permission and only with teacher permission and the correct pass, those students will be allowed to make their way to the pit now.
Is there anybody that will still be in this room in 2 minutes? Good. I will be continuing in 2 minutes. I am recording. So, CG is how long? 9. Right? Now I need AG. So I'm going to just add B to G. Not B to G, dummy head. F to G. So A to G is the red plus the blue, yes? How long is that? The whole thing. A to G is 12. Wait a minute. 9/12. What's that? 3/4, which is 0.75 and 75%, isn't it? Interesting. Okay. Well, what happens when I come along and I do the last one? What's the last one? D to H. All the way down here. How long is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? And what's A to H? $20. Wait a minute. What's that? 3/4. Agreed? Now, What happens if I go ahead and I take my pen and I draw the hypotenuse here? What did I make? What does that hypotenuse make? A big triangle? The big triangle is ADH, correct? And then it makes a middle-sized triangle, which is what? ACG, right? And it makes a little triangle, which is what? ABF, yes? What is the thing that is shared by all of them? What is the thing that is shared by all three of those triangles I just made? No, because AB is not the same hypotenuse as AC. And what's the thing that's the same in all of them? The ratio is the same in all of them, yes. But what else? That angle is the same in all of them, isn't it? Right? Now, what do you know about things like that? In a right angle triangle, the sides always make the hypotenuse when you square them, right? Well, is this a right angle triangle? Yeah. We know it's a right angle triangle, don't we? Right? Because 3 and 4 will make 5, yeah? So we know it's a right angle triangle. This angle, when I compare these two sides, was 0.75, wasn't it? Now, if I keep that angle the same, but I make those sides bigger, what happens when I compare them? Because it's not the same triangle, is it? It's definitely a bigger triangle. You guys can see that it's a bigger triangle. But when I compare the two, what do I get? Same number. And then in this third biggest triangle, is it the same number? It is, isn't it? What if I drew this black line all the way back to Daniel, and I drew this green line all the way out to the wall out there? And then I compared me to the wall and Daniel to there. What would happen when I compared them? It'd be the same. What happened if I drew this black line all the way to Whistler? And I drew this green line all the way to the top of Harrison Lake. What would happen when I compared the two lines? It would be the same, no matter what. Everybody understand? Okay, so what do we take from that? Regardless of side length, the ratio between the two legs of a right angle triangle will be the same. Does everybody understand what I am saying? All right. Now, we're going to do something a little funky on this graph. Take your pen and put an X somewhere between F and G. It doesn't matter where. Just put an X. All right? And then go up, straight up from your X to where the black line meets. And draw that line. Am I still dealing with this same angle? So without even counting these, what would happen if I count that and divide it? What do I get? What am I going to get? 3/4 or 0.75, regardless. Does everybody understand? No matter where I put it. What if I put the x somewhere in the middle here and went up to there? What would I get? I would get 0.75, wouldn't I? Everybody understand? Okay, now, what happens if this line goes up to here? Will I still get 0.75? If I do AYX. Why?
Because the angle changed?
Because this angle changed. It's no longer the same. Does everybody understand that? But if I compared this and this to Q and R, what would I get? QR and AQ would be the same as AX and YX. Do you understand? The angle will change what that ratio is, but regardless of the size of the triangle, every angle will give you the same ratio, regardless of how big the triangle is. Are you all cool with that? Okay? And that makes sense, right? Because there's an angle, yeah? If my hands go for miles, it's the same angle, isn't it? The angle changed now, right? So obviously, the comparison is going to change. Cool? That's the basis of trig. If you understand that concept, you can do trigonometry. Which, by the way, most of you, if you ask your parents, they'll be like, trig's hard. So, let's see if we can do this. This is called the tangent ratio. Please, please, please have that memorized. That word. It is true for all right angle triangles. And all it says is this. The tangent ratio equals leg 1 divided by leg 2. Okay? You take the 2 and you divide them. Now, there's a warning here. It has to be done in a special order, which we're going to talk about in a minute. Okay? Look back here at our graph. I'm going to erase the extra stuff that I used to just explain my point. What went first? The vertical or the horizontal line in the tangent ratio? When we made it. It was 3 over 4, 9 over 12, 15 over 20. What did I use first every time? The vertical one, right? Okay. So the special order is this. It is the opposite over the adjacent. Opposite means what in trigonometry? Opposite divided by the adjacent. Opposite divided by the adjacent. What do you think opposite means in trigonometry? Across. Yeah, what's facing it. Does everybody understand that? So right now, who is opposite of me?
Me.
Vicky. Who is adjacent to Vicky?
Sophia.
There you go. Everybody got it? Okay. Adjacent means beside. Opposite means across. Now notice, how many sides are in a triangle? 3. We've given names to 2 of them, yes? What's the third one in a right angle triangle? The hypotenuse. Have we talked about hypotenuse? No. So that's the next thing to remember. It's only opposite and adjacent. No hypotenuse when I'm doing the tangents. Is everybody cool with that? Okay, so now I'm going to do one last thing with our giant triangle here. I want to make sure you guys get this. Put an M anywhere between G and H, and go straight up from there and put an N. What triangle did I just make? Start at A, and then where? A, M, N. Is everybody cool with that? What else could I call it? Could I call it A, N, M? Yeah. Everybody got that? Okay. What then in that triangle is the tangent of A? Which measurement is opposite in this triangle? Is it NM or AM? NM. Over what's adjacent? AM. Is everybody cool? Okay. Now, we're going to do something with your calculator that is the most painful thing in math class for me, because everybody has a different calculator. Everybody get out their calculator. I'm going to show you a picture of mine. Somewhere on your calculator, if your calculator is going to work for you in grade 9 and 10, you need to have these 3 buttons: sin, cos, and tan. Do you have them? Excellent. The next thing that you must see on your screen somewhere, look on the screen of your calculator. If you, Leighton and Vicky, you do not have what I'm about to show them. I'm going to talk to you two in a second. The rest of you, look on your calculator. Somewhere on your calculator screen, you need to see either the word DEG or the letter D. Is it visible on all of your calculators? So you need to either see DEG or a letter D. Do you have it? 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 Bring your calculator to me. If you do not, you look for the button that says DRG, and you push that button until it says degrees. Don't you? DEG.
Oh, at the top.
DEG.
I thought you were on the button.
No. That's why I said on the screen like 4 times. That's okay. All right, so everybody is in good shape. Leighton and Vicky, you need to push the following buttons. Math. Nope, not math. I lied. Don't push math. Mode. Then use your arrow keys to highlight the word degree. Look up on the screen. When you have it highlighted, hit enter. Okay, now you're set. You good? All right. That means your calculator is now thinking about trigonometry in degrees. Okay? Your calculator can think about triangles in a lot of different ways. We want it to think about them in degrees at your guys' level. Cool? Okay, now here's all you do. There's 2 ways to do this. Every one of you push the button that says tan. Does your calculator write the word tan on the screen? If it does, put up your hand. You all do, yours doesn't. That's cool. That's fine. If it shows that, I want tan 35. So you're going to hit tan 35. Leighton and Vicky, get used to closing the brackets. The rest you don't need to. Then hit equals. And you should all get that. Do you? Okay. In trig, we like 3 decimal places. 0.700. Does everybody understand? I'll help you in a sec, Blake, I promise. You got to reverse it, but I want to say that for the video. If your calculator doesn't do that, then you got to reverse the buttons. You would hit 35 tan. Everybody else is hitting tan 35. Sometimes equals, sometimes not. You probably didn't need to hit equals. Okay, so what does that tell us? 0.700, right? That means I went up about 7 and I went that way about 10. Does everybody understand? Okay, so you guys tell me what the tan of 15 is. What is it? 0.268. We like 3 decimal places, right? Cool in the gang?
I got 267.
You got 0.2679, which is 0.268. And 45.
1.
1. Everybody got it? All right. Now, I'm just going to take a second to explain why this is 1. If that's 90 and that's 45, what does that have to be? How many degrees are in a triangle? 180. So that has to be 45, doesn't it? If that's 45 and that's 45, aren't these both the same? Right? So if I compare opposite to adjacent, and they're both the same number, opposite divided by adjacent is going to be 1, isn't it? That's why it works. Everybody cool? No matter how big I make this triangle, if I go 10,000 kilometers this way, and then I turn left, I have to walk 10,000 kilometers that way until I've made 40 degrees, 45 degrees. Understand? Okay. Now, that gives me the ratio. Now, that ratio is attached to this angle, isn't it? Right? We can also use our calculators when we have the ratio to find the angle. It reverses. Now, we know that 0.75 is the angle we were working with up top, don't we? But do we know the angle? No, we just knew it was angle A. We don't know how much it's worth, do we? So we're going to use our calculators to tell us how much it's worth. This is the ratio. The angle is as follows. For everybody but Blake, you must go. Find the second button. You must find the shift or the second button on your calculator. Or it might also be INV. One of those 3 buttons. Does everybody have it? So you must push second, or I'm going to use an S for shift. Shift tan 0.75 equals. Blake, and anybody else with a backwards calculator, you must push tan, 0.75 shift tan. And you might have to hit equals. And what do you guys get? 0.75. Which is almost 37 degrees, right? So we round that to the nearest degree. Is everybody cool? Now, watch this. I want to make sure my lines are perfect. Cool? Okay. Now, I used to have a tool on here that would do this, but I don't anymore because on my new computer. So I'm going to show you like this. Thieves. Thieves. Protractor. And you can see that this line is going right out there, right around 37. Everybody understand? Okay? All right. So now use your calculator to find the next two. Follow the rules. What's this one? Shift, tan, negative 1.23. Negative 50? Yeah, negative 51. What? How can you have negative degrees? You can't. They don't exist. Right? So let me show you something. How many degrees are in a circle? 360. So if I start counting here, that's going to be 360, right? If I go all the way around. Agreed? But I'm not going all the way around, am I? I'm going 51 less, right? So I'm really going 90, 180, 270, right? This would be 360, but I don't want to go to 360. I want to go 51 less than 360. So I'm going to go to about here, right? That is my minus 51. What's 360 minus 51? 309, right? Tell me, go ahead with your calculator and do the tan of 309. What do you get? Negative 1.23. What? What are you trying to do? Second, tan. Why do you have both buttons there? Oh, you just got it. You got a weird calculator. You just got to hit the button twice. You don't use second. So second tan of negative 1.23. So you just got to hit the button twice. That I have never ever seen that. Damn it! That's now a third thing I have to explain when I do this. Not your fault, Jesna. Stupid Texas Instruments' fault. All right, so everybody cool with that? You won't see this in grade 9. I just wanted you to see it. What it looks like. And finally, what's C? Shift, tan, 2.5. So that's 68 degrees. Can everybody do this? Okay. Now remember, it doesn't matter about the size and it doesn't matter about the looks. These rules apply. Okay? For any angle. Now, when I say any angle, what's the one angle I don't mean? Right. It's not the right angle. It's for any angle, not the 90 degrees. It's for the other two. The tangent ratio compares the opposite side to the adjacent side. Now, when I sit here and I make a triangle with me, Vicky, and Leighton. No, I'm going to use Sophia because Sophia's right beside her. If we draw that triangle between our heads, who is opposite if I'm the one doing the looking? Where's opposite? the girls. Where's adjacent? Right here. Agreed? This is what it looks like, yeah? Me, Vicky, Vicky, Sophia, Sophia, me. So if I want to do a tangent, it would be Vicky, Sophia over Vicky, me, right? What if Sophia is doing the tangent? Now what's opposite? Vicky, me. And what's adjacent to Sophia? Sophia, Vicky. Understand? It's opposite and adjacent from where you are looking. Okay? If I move in the triangle, what I see in the triangle changes. Do the numbers change? No, but their position changes. Understand? So, right here, where is angle A? It's right there, yes? So I want the tan of A. Tangent is always what? Opposite over adjacent, yes? So when I'm at angle A, and I'm going to draw myself at angle A, there I am. What is opposite to me when I'm at angle A? Across the triangle, what do I find? What number is it? It is BC, and it is 12, correct? All right. What is adjacent to me? There's two that are beside me, aren't there? One of them is AB and one is AC. But AB already has a special name, doesn't he? What is it? Hypotenuse. What did I say about tangents? Do they ever use hypotenuse? No, so it must be AC, which is what number? 5. Everybody with me? Now, I am going to go for a slide. Whee! Whoomp. Now I'm down here. Now I'm at B. So what is my tan of B? Well, tan is always opposite over adjacent, isn't it? But where am I now? I'm in a different spot. What's opposite to me now? AC, which is 5 over BC, which is 12. Do you all see how it works? Where you are decides what's opposite and what's adjacent. What didn't change when I moved? The numbers, they just changed position. And what in the triangle didn't change no matter where I was standing? The hypotenuse, right? Because no matter where I am, the hypotenuse is always the hypotenuse. Everybody cool? All right. You're sure? Okay. So you should have a bunch of blank space now, yes? Good. We're going to draw 3 triangles, and I'm going to see if you really get it. X, Y, Z. I want you to do 2 things with this triangle. 1, label the sides properly. I told you on the very first page of these notes how we label sides. Then number 2, I want the tan of both angles that I can use. Because one of the 3 angles we're not allowed to do the tangent with. So, I'll let you think about it for a sec. Talk to your neighbor.
There's 2, right? Yes, so 2. What's the sides would be no, I think this is the hypotenuse. Because Who's the angle and who's the best? I mean, yeah, because like, we want to label these, right?
Okay. So let's label first. What label would I give this along the bottom?
Y.
Little y, because it's across from big Y. Good job, Vicky. What label do I give this side? Little x, because it's across from big X. So what is this side? Little z. Everybody cool? So that's labeling. Now I want the tan of the angles that I'm allowed to tan. What are the two angles I'm allowed to tan here? Neither. Tanning's bad for you. But seriously, what are the two angles I'm allowed to tan here? Tan of x, and what's the other one I can tan? Tan of z, because y is the 90. I can't tan 90. So, is there any numbers on this? So I have to do my tan with letters, don't I? Okay, so what is opposite of x? Y is the hypotenuse. Little x over what's adjacent? Little z. Now, I'm now over here. I was here. There I am. I looked opposite and then I looked adjacent, right? But now, I'm walking over here. Now what's opposite? Little z. And what's adjacent? Little x. Does everybody understand tangent? Everyone's got it? Okay, I'm going to draw one more. I'm going to turn it funky like, and I'm going to see if you can figure it out. Okay? So, label it. And tell me the tans that you're allowed to have. What's this guy? Lil B. What's this guy? Lil I. What's this guy? Lil Q. Good. What are the two tans I'm allowed to get? Tan of I, which is what? Tan is always opposite over adjacent. So what's opposite a little big I? Little I, and what's adjacent? Little b. What's the other tan I'm allowed to get? Tan of big B, which is always opposite over adjacent. What's opposite of big B? Little b. What's adjacent? Little I. Everybody got it? What if there were numbers there instead of letters? What would you put in here? You'd put what? If I told you little I equaled 12, what would you put right there? 12. What would you put right there? That's trig. Can you believe that people find it difficult? You had to learn two words, opposite and adjacent. If you know those two words, you can do trig. Everybody ready? All right. So in number 4 there's an x, right? X is an angle, isn't it? If I want an angle, am I doing tan or shift tan? Look back in your notes if you need to. Shift tan, right? So x is an angle, so I need shift tan. And here's what I do to do trig. I write out the following 3 things. I make a circle with a line through it. That's a Greek letter. That Greek letter is theta. It means an unknown angle, or an angle you're going to work with. Cool? So, do you know the angle that you are working with? Yes or no? It's x, right? Okay. Now, if x is the angle that you're working at, that's where you're standing, yes? So you know, what do you know about this triangle? You know that, which is what? Opposite or adjacent or hypotenuse? Opposite, isn't it? So you have an opposite that's 23, correct? And what's this 15? Adjacent, which is 15. Now what do you know? You know that the tan of any angle, which is x, must equal opposite 23 over 15. Right? Now, do I want the tan? No. I want the angle, don't I? So I need the tan. -1 means shift tan. I need the shift tan of x. How do I do that on my calculator? How do you make that something you can work with? Well, that's shift tan bracket. What math is this? 23 divided by 15, close brackets, equals. And that will give you the answer. So let's check. Shift, I got to turn my calculator on, shift tan, 23 divided by 15, close brackets, equals 57 degrees. Now, Blake, you got to reverse it. 23 divided by 15 equals shift tan. And what do you get? $56.88, right? 57. 23 divided by 15. Put that in brackets, right? And then hit shift tan. Got it? All right. So, in this second triangle, I'm going to get you guys to set it up. And then we're going to work through it. In the third triangle, you're going to do it totally yourself. So the first thing I need is a theta. Do I have an angle that I know in that triangle? What is it? 15. So I've got a theta, correct? That means I'm starting up here, right? There I am. What do I know? I have an opposite. What is it? X. I have an adjacent. What is it? 37. Then I just write it out. The tan of my angle. What's my angle? 15 equals opposite x over 37. Now you guys know how to solve an equation, right? How do you get rid of that 37 so x is by itself? Multiply both sides, right? So I multiply this by 37. They're going to cancel, aren't they? Leaving x alone, which is what I want, correct? What do I got to do to this side? Multiply by 37. So how do I do that on my calculator? 37 times tan 15. What if I was Blake? 37 times 15 tan. What do you got to hit at the end? What button you have to remember to hit at the end of your calculating? Equals. If you don't hit equals, you're not going to get the right answer. Blake, that applies mostly to you, because as soon as you hit tan 15, your calculator screen is going to fill up. That's not going to be the right answer, is it? Got to hit equals. So what is it, guys? 9.9. No. With sides, we would leave it as 2 decimal places. It's only angles that we round off. Okay, so I go to my calculator. I go 37 tan 15. I don't even need to push times on my calculator, equals 9.91. Everybody got it? Okay, you guys try to do that one totally by yourselves. I'm going to just remind you how to set it up. You need a theta and then whatever you have. Then I'm done. Your homework's the rest of those. There's 4 more questions on there. That's your homework. Stop at the next heading. I'll wait a minute for you guys to fill this part in, though, before I hand it out. I mean, before I show you the right answer, dummy. All right, so what was my theta? 70. That means that's where I am, right? Okay, so what do I have? Do I know anything else about the triangle from where I'm standing? I know the opposite is what? 14. And the adjacent is what? X. What else do I know? I know that tan of 70 must equal O over A, correct? So tan 70 must equal 14 over X, right? We're going to do this algebraically, and then I'm going to give you the shortcut. I need X by itself, right? Is it allowed to be at the bottom of a fraction? No. So I'm going to multiply both sides by X, aren't I? Right? Cancel. So now I'm going to get X tan 70 equals 14. And this is multiply, right? What do I do to get rid of this multiply so X is alone? Divide by what? Tan 70. If I divide one side by tan 70, what do I do to the other side? Same thing. So X equals 14 divided by tan 70. Now you guys are smart kids. When the variable was on the top, what did we do? This is the shortcut. When the variable was on the top, what did we do? Multiply. When the variable was on the bottom, what did we do? Divide. Done. How do I punch that into my calculator if I'm everyone but Blake? What do I got to punch in? 14 divided by tan 70 equals. If I'm Blake, 14 divided by 70 tan equals.
5.
5 what?
0, 9, 5, 5.
14 divided by tan 70. 5.095, which would be 5.1, right? Can everybody do tangent? It's easy peasy, right? If you can see and you can push buttons, can you do trig? Good. You have 4 questions of homework. Now, remember, even though we only learned about tan today, you already know something for finding stuff in triangles, don't you? Pythagoras. Do you get to forget Pythagoras? No. Remember Pythagoras. Do the rest of this, and that's your homework. If you get it done in 5 minutes, you got no homework.